All right, guys, we'll start quickly. Thanks for being here. Please mind my voice. I'm a little sick, so if you are not clear what I say, just feel free to put it in the chat or open the mic and speak up. The recording has been started. We'll be posting the recording by tonight. All right. So I just want to quickly skim through the syllabus. So just give me a second. I hope the screen should be visible now. Yes. So, uh, talking about problem stats, which is Marks 2 for you, right? So, first unit, we are dealing with the basics of probabilities, right? So, firstly, we learned what an outcome is. What do you mean by a random experiment? Then, set of all outcomes, you make it a sample space, right? Then, whatever is favorable to you, you call that an event, right? And you try to find the probability of that event happening, right? Then you went into different definitions of probability. There are empirical definitions of probability. There are set theory based definitions. So you did some operations on finding probabilities using sets. Okay, we'll be seeing that and all. Don't worry. And then we had probability actions where we learned about the multiplication rule and the addition rules and all that. And we also learned about some applications of permutation, combination, and probability. Yes, different possibilities. Yeah. Then we learned about conditional probability where given something has happened, what is the probability of something else to happen? Yes. So in conditional probability, we saw that the sample space reduces to the given set. Yes. Then in independent events, we saw that the probability of A and B happening would be nothing but P of A into P of B. They are independent of each other. We derived independent events from the definition of conditional probability itself. We'll be seeing that. Mutually exclusive events do not overlap. Yes, their intersection is null. And then we learned about marginal probability, joint probability, and Bayes theorem. Yes, we also learned about total probability, right? Given E1, E2 till En, the probability of E happening is probability of E1 happening into probability of E given E1 happening, and so on. You do it for all the events, right? Next, we learned about the discrete distributions firstly. Then we learned about continuous distributions, right? In discrete distributions, we first learned about how do you define few discrete terms, right? So defining a probability for a discrete function would be a probability mass function. We learned about probability of x is equal to x, right? So this is a probability mass function. And we also learned about cumulative distributive function. That is what probability of x less than or equal to x. It is cumulatively adding up from minus infinity till this point x. Yes, great. But the point here is it is discrete. It is not continuous from there. It is in steps. Whatever you specify, only those points will be considered. Yes. Then we learned about expectations. Yes. Please give me a second. All right. So, expectation we learned, in which we expressed expectation as a mean, looked upon few properties of expectation, and we play around expectations a lot throughout this chapter. Yes. Then we learned about variance. Variance is again another term that comes from we all have learned it in somewhere around 11th or 12th. We learned about standard deviation and variance. Yes. Represented by sigma square, sigma being standard deviation. Yes. How your data points differ from the original mean which you have. Yes. So we are also interested in why that formula works and all that. We'll be seeing that. All right. Next, conditional expectation and variance. We have different types of distributions, right? So we learned about binomial distribution, right? We also learned Bernoulli, yes. We also learned about uniform distribution, Poisson distribution. I don't think you have exponential. Yes. Yeah. That. Then in continuous random variable, you also learned about continuous distributions, right? And how do you define probability in continuous? You put it as PDF, right? Probability density function. And CF is still the same. Cumulative distribution function. Yes. Then we learned how to evaluate integrals and all that for different probability terms and all that. Then we looked upon different distributions, right? How do you put thing? And importantly, yeah, normal distribution, yeah, standard normal distribution. How do you do that? Generally, they won't ask you to find the probability of a normal distribution. Generally, it is a standard normal distribution across a variable called Z, the standard normal variable. Yes. I don't think you have this. I think unit 4, there is something incorrect. I think unit 4, yeah, you did learn about CLT, central limit theorem. Yes, beautiful. Then we learned about two-dimensional random variables. Yes, two-dimensional random variables. You learned about firstly computing. When you have two random variables, how do you evaluate the probabilities? What are the different notations that you use? Yes. I have a nice PDF which my lecturer used and shared with you. Yes. So in two-dimensional random variable, firstly you learn about how in one-dimensional you had something called PMF, something called PDF, right? What do you have here? Here you have different terms. Here you have different terms, right? So you have uh, probability of x equal to x, y is equal to y, px of x, py of y, and then P of x equal x given something like that. Yes. So what is this? This is joint probability distribution, marginal probability distribution, and conditional probability distribution. Very simple, right? So here, if x assumes a value of x and y assumes a value of small y, right? Then what is the combined probability? That's it. Very simple logic, right? I have till this moment I was only having x or I was only having y. What if I had both, right? Probability of x equal x and y is equal to y. Then that is going to be joint probability thing. What if I just want to compute one thing? If you want to just compute one thing, then I do not set any bar on y. If I do not set any bar on y, then I can add up all the values of for a particular value of x, I can add all the values of y. I do not have any bar on y, right? So that is going to be the marginal distribution, right? Then conditional is usual. Generally, p of x given y will be given as p of x intersection y by p of y, right? In this case, the intersection is regarded as the joint one. So it will be p of x comma y, right? And p of y would be regarded as what? Just py of y, right? So that is what you had. And unit 5, I'm not really sure. That is new for me. So I leave it to you guys to revise. So I'll be taking only the first 4. Yes. Yeah. Done. Maybe I'll quickly revise through and see if I can put a voice recording by tonight. Okay. Yeah. So till this moment, do you guys have any doubts? Is there something that I should resolve? Is there any concerns from your side? Yeah, I forgot to mention this. You also had covariance, correlation, regression lines, right? Those are very important. 100% question will be coming from that region. Okay. So covariance, correlation, and regression lines. Yeah. How your data points vary, how your data points are scattered around, and how do you fit it into a line? There are various data points. I want to fit that into a nice line in such a way this error is minimal, something like that. Okay. So how do you find that line and all that? We'll be dealing with that. Yeah. So if you don't have any doubts, can I have a thumbs up from your side? This will be a very shorter session only. Okay. Can I have a thumbs up from your side? Yes. Thank you. Thank you. Okay. Next, we're going to deal with different types of distributions. Should I go through that? Okay. General formulas, right? So how do you represent probabilities in terms of sets? So this is one event A. Sorry for the clarity. This is one event A. This is one event B, right? So probability of A is nothing but the whole set A, right? Similarly, this is probability of B. Just chumma Venn diagram, learn it. Yeah. What is probability of A bar? Everything except A. Universal set minus A. Just leave this area and everything. This is probability of B bar. Beautiful. Probability of A intersection B is this part. Beautiful. A union B is A, B. You have subtracted it twice, so subtract it once. Minus P intersection, minus P of A intersection B. Beautiful. Next, mutually exclusive is they do not overlap at all. Their intersection is null. Yes, and the probability is 0. Yes. Conditional probability P of A given B would be P of A intersection B by P of B. Right? Why does this happen? Because your sample space reduces to one set, the given set. Yes. So P of A given B would be just P of A intersection B by P of B. So this also makes clear that P of A intersection B is equal to, this is conditional probability, right? So P of A intersection B is P of A given B into P of B. This is a general rule of two things happening at once. Let's say P of A intersection B, meaning A and B should happen, right? A and B should happen. In that case, B should happen. Given that B has happened, A should happen. What is the probability? It's very simple, right? Probability of A intersection B is equal to what is the probability of B happening multiplied by what is the probability of A given that B has happened. The same way you can also write it as P of B given A into P of A, right? A has happened, probability of B given that A has happened. Yes, beautiful. Next, we try to learn independent events. When two events are said to be independent, then they do not depend on the occurrence of the other event, right? So in that case, P of B given A, irrespective of A happening or not, it will always be P of B only. The same way, P of A given B, irrespective of them happening, it will be always P of A only. So in that case, you can write this as what? P of A intersection B is P of B into P of A or P of A into P of B. That is independent. Okay, great. Next. One second. What is and then we learned about total probability, right? So total probability, what do? P of E could be nothing but I want the occurrence of E, right? E can occur in multiple ways. E has intersections with E1, E2 till En, let's say, right? Then probability of E is given by the formula. Let's say E1 happens. If E1 happens, what is the probability of E happening under E1? Simple, right? The same way, what is the probability of E2 happening? And E kulla, what is the probability of E2 kulla, what is the probability of E happening? And so on, right? Probability of E3 into probability of E given E3 till this. So this is the entire set. This is going to be the total probability, right? Great. Now, given that E has happened, what is the probability that it is from E1, right? Given that E has happened, what is the probability that it is from E1? Then how do you do this, right? So you use something called Bayes theorem, the reverse approach, right? Generally, you find the probability of E, but they have told E has happened. Then what is the probability that it is from E1, right? So let's apply the general rule. P of A given B is P of A intersection B by P of B. Yes. Now P of E1 intersection E using multiplication theorem. Multiplication theorem which we saw that. It is going to be equivalent to what? P of E1 into P of E given E1, right? P of E1 into P of E given E1. Agreed? So this is what is Bayes theorem. P of E is a total probability, right? You compute everything for all the possibilities. It is going to be P of E1 into P of E given E1 plus P of E2 into P of E given E2 and so on, right? This is going to be just numerator P of E1 into P of E given E1, right? Whatever you are interested in. If this is 2, these two will be 2. Yes. So this is what Bayes theorem we saw. Yes. So I think that brushes up the first unit. Okay. So we look through my PPTs as well once. Okay. I just want to go through these formula sheets I took from Google. Okay. Next. So we learned about discrete and continuous random variables. Okay. So discrete is in steps. It is not continuous. There is no interval here. Continuous is from intervals. You cannot pick out a random point and say something. It is always occurring in intervals. So probability is also integral based. This is summation based. Okay. So moving forward, discrete random variable. First, there are few probably key terms, right? for statistics, mean is expectation, that is E of x, right? E of x is given by the formula summation of x into P of x for all the values of x, okay? So if it is expectation of x, it is x into P of x. If it is expectation of x square, what is it? Expected summation x square into P of x, and so on, right? So it will always be summation of whatever this term here, summation of that term into probability of x. That's it. Yes. So if it is expectation of e power tx, it will be what? Summation e power tx into P of x for all the values of x. Okay. That is something we define as MGF. We'll be coming to that. Okay. Next. Variance is sigma square. And how do you define variance? Variance is expectation of x square minus expectation of x the whole square. There's a beautiful way of projecting this actually. Okay. So how do you project this? You have a lot of values. Okay. Now this is having a central value that is a mean. Yes. How each data point varies from this mean is going to tell you the difference. All these is going to tell you the x minus x bar difference. This could be x1, this could be x2, this could be xn. X minus x bar will be given. Again, this has a lot of differences. I want one single value that tells me how data points differ from my mean, right? Then what do you do? First of all, this guy is, I don't like this guy since this guy is positive, this or negative or something like that. Yeah, I try to square this guy. Yes. Again, squaring this guy makes it positive, but again, this has a lot of values. So what I'll do is I'll try to take the expectation of it to give me one single value that tells me how my data points vary from the mean. So that's why I take expectation of x minus x bar the whole square. This will give me, so if you try to simplify this using the role of expectation and all that, you will get it. E of x bar minus E of x the whole square. E of x bar being the second raw moment. I hope you guys learned moments. So moment, any in general, R moment is given by E of x power R. Yes, this is first raw moment. So mu2 dash minus mu1 dash the whole square. Yes, just give me a second. Just give me a second. Just give me a second. Guys, yeah, are we on the same page? Is everyone on the track? Just give me a quick thumbs up. Okay, okay, okay. All right, right, great. Yeah, a standard deviation is square root of variance. Yes, and moments is given by expectation of x power r. So if it is expectation of x power r, it will be given by summation x power r into p of x equal to x. Yes, for all the values of x. Right? There are different kinds of moments. Moments about this is a raw moment because you do not subtract anything from x. If you are subtracting it from, let's say, a point like A, it is going to be about a point A. About a point A, you call it like this. Generally, you will not have something like that. Yeah. About mean is going to be the central moment. About mean is going to be the central moment. So you put x minus x bar into P of x equal to x. Okay, great. Similarly, for a continuous random variable, it will be the same thing with an integral. Yes. So in this case, mean would be what? Instead of summation, you put integral. X would be just x. P of x would be f of x because PDF, right? For all the values of x, how do you signify minus infinity to infinity? Be mindful of this fact that you have to only take the limits that f of x agrees to. Yes, f of x only agrees to a certain domain. Okay, please work on that. Wherever f of x is defined, take there. All the other places, it could be defined as 0, so you can work accordingly. Okay. Next, variance also expectation of x square minus expectation of x the whole square, where expectation of x square obviously would be x square into f of x. That's it. Okay. Next. Again, moments would be what? Integral minus infinity to infinity for all the value of x power x power r into f of x dx. Yes, the same thing, same thing. And you subtract from x bar in the case of about the mean case. Beautiful. Moving forward with the discrete non-variable distributions. Okay. I suppose this has only a few things, but okay, no worries. So how do you denote this? Binomial of n comma p. N and p are the parameters, right? N is the number of items you have, number of things you're looking for, and p is the probability of success, right? Then q would be the probability of failure, that is 1 minus p. Yes. So the probability is given by what? NCx, p power x, q power n minus x, right? NCx, p power x, q power n minus x. Yes. And the mean is given by NP and variance is given by NPQ. Okay, great. Next, Poisson. The Poisson case, you have a parameter called lambda, right? The binomial case converges to this Poisson case, right? So how do you define that? It will be nothing but, I think it should be lambda par x e par minus lambda by x factorial. Okay, that is the probability. And I think it should be the same thing. The lambda is going to be the mean and lambda should be the variance. Okay. We'll quickly look through these formulas once again. I'm not really sure. Okay. Yeah, let's take up my PDF and see that. So till this moment, do you have any queries? If not, just quick thumbs up, please. Okay. Yeah, thank you. Just give me a second. Yes. This is one of the formula sheets I made when I learned this concept. So moment generating function is expectation of e power tx, discrete case, continuous case. We have seen it already. Okay. And we derive it, how you derive it and all that you should know, right? Generally, e power x is given by 1 plus x square by 2 factorial plus x cube by 3 factorial till infinity. So you put it as e power tx, then take expectation. That will give you a formula like this. That will give you a formula like this. That is 1 plus t into mu dash plus t square by 2 factorial into mu 2 dash plus t cube by 3 factorial into mu 3 dash and so on. So in general, if you want to find mu r dash, then just do what? The coefficient of t per r by r factorial. Coefficient of t per r by r factorial will give you mu r dash. Beautiful. And the derivative of mx of t is going to give you with that 0. I missed a 0 there. Given that t is equal to 0. Okay, it's going to give you a mu r dash, right? Derivative of mx of t, rth derivative is going to give you mu r dash with t put 0. Okay. Then general sequences, just know this 1 plus x squared till infinity. This is what arithmetic, geometric progression, that is a by 1 minus r if sum of infinite terms. Yes. So in this case, it is 1 by 1 minus x. Similarly, this 1 by 1 plus x, 1 by 1 minus x, the whole square, and so on. Yes. Integral of e power ax dx is e power ax by a plus a. Just want to know that. Yeah. Next. Binomial distribution. There are two outcomes only, success, failure. The parameters are n and p. N being number of trials, p being probability of success. Yes. Then q is probability of failure. Yes. So x is going to tell you the number of successes of n trials. Yes. So p of x equal to x meaning how many successes do you want? So NCX, P par X, Q par N minus X, right? Mx of T is given by Q pet, Q plus P E par T par N. Okay, if you want to remember these functions, real well and good. If you don't, you can always derive this. Very simpler derivation only. Okay, so Q plus P E par T whole par N. Okay, the mean is going to be NP, the variance is going to be NPQ. So standard deviation is root of NPQ. And obviously P plus Q is equal to 1. Probability of success plus probability of failure should always be 1. I don't think you have exponential. Poisson. When does Poisson occur? When N is really large and P is very small, meaning the number of items you are assessing is very large, but the probability of that success is very small. In that case, N and P, when you multiply, converges to one value called average rate, and that is going to be called as lambda. Yes. So probability of X equal to or minus lambda and lambda per X by X factorial. Just remember this. Okay. I know some intelligent minds who reverse this. So please remember the formula correctly. E per minus lambda, lambda per X by X factorial. Okay. Next. Mx of T, if you want, you can remember or leave it. The mean and variance both are lambda only. Yeah. Fine. Next, uniform distribution. Uniform distribution is a continuous random distribution. Yes. So here you will always have an interval defined. Yes. So the parameters are the endpoints of this interval, A and B. Yes. So how do you define the probability density function for this? 1 by B minus A. 1 by B minus A. Whenever it is lying from A to B. Understand this, right? Only when it lies from A to B, the probability is given by 1 by B minus A. Otherwise, it is defined as 0. 0. Yes. So, please be mindful of the fact that the interval is only defined in few contexts, right? So, the interval could be defined in just -3 to +3. But they might ask you probability from 0 to 4. Yes. In that case, it is not defined from 3 to 4, right? 3 to 4 probability is just 0. Please don't integrate it from 0 to 4. Integrate only from 0 to 3. 3 to 4 probability will be 0. Right? You can mention that. Yes. Next. What is the mx of t for this? It is e par bt minus e par at by bt minus at. Okay? Yes. If you want to remember this, you can. Else leave it. Right? But you should know the mean and variance and all that. That is important for sure. Okay? Just give me a second. Reduce the pen size. Do I reduce this here? Raw. Okay. Fine. Yeah. And what is the mean for this? B plus A by 2. What is the variance for this? I think B minus A whole square by 12. Okay. Beautiful. Yes. So whenever they ask you probability of X greater than or equal to something, right? So in that case, probability of X greater than or equal to X, you usually take what X to infinity, right? But X to infinity is not defined here, right? It is only defined till the end point B. That is the highest end point. So X to B and then B to infinity it will stop, and B to infinity will always be 0. So X to B will only be defined, right? Similarly, the same case, when you want to define probability of X less than or equal to X, X less than or equal to X, in that case also, it will be minus infinity till X, but minus infinity to X is not defined. So it will be splitting into minus infinity to A and A to X. Minus infinity A will be 0. So A to X will only be there. Yes, beautiful. Next, normal distribution and CLD. So in normal distribution, you will have a nice, sigmoid curve. Yeah, sorry, bell curve. Yes. So the parameters are mean and variance, right? The Z standard normal variable is given by X minus mu by sigma. X minus mu by sigma. Yes. Where mu is going to be the mean and sigma is going to be the standard deviation. Yes. So you may not remember this, right? Leave it. But yeah, so the probability, so generally you'll be evaluating probabilities only in this context, right? Probabilities only in this context. So the probability of Z, so there are different kinds of graphs in which you will be computing probability for, right? So the probability of, let's say, Z lying between A and B. So you'll first find Z, whatever X is given, let's say you're finding X from A to B, then what do? You in this whole inequality, you try to subtract mu right? And you try to divide sigma, divide sigma, divide sigma. Yes, beautiful. Next, you are going to what? Find the probability of z lying between these two things you have a and b. You subtracted something, you got a. Subtracted, divide something, got b. Now, how do you compute this probability? It is ranging from A to B. The table that will be given to you will be the table that starts from 0 till the point you have. It will only give you the probability, the area from 0 till the point you get, right? So it will not give you the endpoints, A and the B key, it will not give you, right? So in that case, what do? You take the value from 0 to B. You take the value from 0 to A, right? You subtract it. You get easily the area between A and B. That's it. Yeah. That is going to give you the answer. Next, probability of z greater than a. So I have an a. I have an a. Probability of z greater than a. So in that case, what do I do? I very well know a bell curve is a very nice curve. Here it will be 50%. Here it will be 50%, meaning 1 by 2, 1 by 2. Okay, this half 50, half 50. Yes. So in that case, probability of x, probability of z greater than a, right? So let's say a is here, x greater than a is this area. So what I do is I take this till infinity. That will give me 1 by 2, right? Minus, I'll take 0 to a. That will give me some value, probability of x from 0 to a. Okay. Now, overall, if you see, that is going to give you this area, probability of x greater than a. So that is the key idea here. Yes. Next, central limit theorem. Central limit theorem you use when you have a lot of random variables, right? A lot of independent, IID you call it. I forgot the terms. Uh, okay, we'll come to that. Yeah. So those random variables, right? Identically distributed independent random variables like that. Okay. So if you have these random variables, they irrespective of whatever distribution they are, if you add them all up, this random variable will be a normal distribution. That is what CLT says, right? So let's say individually they have mu and sigma square as their mean and variance respectively, right? Then you can say that X is going to be a normal variate with the mean as n mu and the variance as n sigma square. That's it. Mean as n mu, variance as n sigma square. Then standard deviation will be sigma root n, right? That's it. So you just have to learn all these up properly. I think that should usually do. Okay. I'll quickly open my PDFs also. So till this point, any doubts, guys? Is it all clear till now? Just give quick thumbs up, please. Quick thumbs up. Okay. I'll quickly skim through your worksheets also. Yeah. So I just want to quickly run through 2D random variables as well. Many people had some issues with this. Okay. Joint probability mass function is x assuming value of xi, y assuming value of yi. Yes. And marginal is probability of, there are two kinds of marginal probability, right? Marginal probability mass function of x, marginal probability mass function of y, right? For x, px of x, find all the probability of p of xi comma yj in such a way that you are fixing x, right? And you are finding it for y, meaning the j values are looping over. You add all the values of y, okay? And do the same for y as well. So let's look at it in the table. That'll be easier. I don't think you have continuous case for this. You don't have la. Okay. So given something like this, the joint probability mass function of x comma y is given by p of x comma y is equal to k into 2x plus 3y, where x assumes these values, y assumes these values. Make a nice table, right? Make a nice table like this. Okay. X assumes what and all values. X assumes 0, 1, 2. And y assumes which and all values, right? Y assumes 1, 2, 3. Yes. Now they have told p of x comma y, that is joint probability mass function, is given by k into 2x plus 3y. Substitute the value of x, substitute the value of y. That will give you something in terms of k. In terms of k, it will give you. Add everything up. That will give you the value of k. Because adding all the probabilities will give you 1. So you got the value of k beautifully, right? So you'll make a nice table like this, right? Forget these two columns. Forget this. Forget this. Yeah. This is just a joint probability, right? Nicely. Now, for finding the marginal probability, what do you do? Fix something. If you are doing what? Py of y, for a given y, add all the values of x. Add all the values. When x is 0, 3 by 72. When x is 1, 5 by 72. When x is 2, 7 by 7. There is no bar on x. Right? Add all of them up. That will give you Py of y. Same way, add these. That will give you this value. Add these. That will give you this value. Similarly, Px of x would be add all the values. This, that will give you this, this. Yes, beautiful. Next, conditional probability. You have to list out all the possibilities here. Okay, so let's assume for conditional probability of mass function of x given y. So y is given, right? So let's assume the value of y is equal to 1, right? That is the first value of y, right? Y is given as 1, 2, 3. Let's assume y is equal to 1. If y is 1, x can be 0, 1, 2. So we can easily find what p of 0 given 1 given 1, 2 given 1. 0 given would be p of 0 comma 1. That you can take it from table. P of 1. How do you take p of 1? Then that p y of 1. So that will be given in the marginal table which you have, 15 by 72. You see this p y of 1 would be 15 by 72. Yes. So the denominator will be the marginal value. The numerator will be the joint probability value. And that will be the overall conditional value. Yes, you do it for all the possibilities and make a nice table like this. Yes. Yeah. And then you can also you can also do this x plus y values. What are all the probabilities of these things which add up for x plus y, right? X plus y, what are all, find all the values of x plus y, and for which values of x plus y is the current value defined for. X plus y can be 1. Which pairs of x and y gives me 1? Just 0, comma 1 pair gives me 1. What is the probability of 0, comma 1? Simple, 3 by 72. Take it from the table. Yes. Probability of x plus y is equal to x plus y can be 2 in multiple contexts. Yes. What are all the possibilities of x and y? That gives me a 2. These two possibilities. What are their probabilities? Add them up. Yes. Make a nice table like this. Beautiful. Yes. So this is the general one. Okay. You should be able to do this. 100% questions will be coming from this region. Okay. Covariance correlation. How do you do this? It is going to help us quantify a relationship between two variables. Yes. So this is, you can very well see this. This is a large negative covariance, large positive. How scattered it is. Yes. Nearly zero covariance. Yes. So covariance formula is, you must know this. You must know this. Covariance of x comma y is given by expectation of xy minus expectation of x into expectation of y. There's a very nice way of deriving this, very beautiful derivation. You can always go through this. Expectation of x minus x bar and y minus y bar. How x differs from its mean, y differs from its mean, take the whole expectation. that you will arrive at something like this. Okay. So yes, you can see these properties, beautiful properties. Yes. Covariance of Ax, comma by, A and B will come out. X plus B, Y plus B doesn't matter. It's the same as covariance of X and Y. Ax plus B, Cy plus D, same thing. B and D doesn't matter. AC come out. Yes. Covariance of X and X would be what? Covariance of X comma Y is given by expectation of XY minus expectation of X into expectation of Y. If Y itself becomes X, it becomes what? Expectation of X square minus expectation of X the whole square. You see that beautifully? That's why it is variance of X. Yes. And when expectation of X is equal to expectation of X into expectation of Y, then obviously what? The covariance is going to be 0. Because covariance is nothing but expectation of XY minus expectation of X into expectation of Y. That becomes 0 when they are independent. Okay. So just know these formulas. Again, this formula as well. Variance of X plus Y is variance of X plus variance of Y plus 2 covariance of X comma Y and so on. Correlation again talks about the strength of the relationship. You can very well see this perfect correlation, positive correlation. This is perfect negative correlation and no correlation, negative correlation, positive correlation. Okay, beautiful. The correlation coefficient should always lie between -1 to 1. Okay, yeah. And how do you find the correlation coefficient? Rxy would be nothing but given by covariance of X comma Y by sigma X, sigma Y. Covariance, you just find it using the previous formula. Sigma X, sigma Y are nothing but the standard deviations of random variable X and Y. Okay, beautiful. Next. If the covariance is 0, obviously correlation is 0. Yes. So you can easily do this, right? Firstly, make the joint probability distribution table, then make the marginal distribution table by setting values, default, by putting something constant. Yes. Then you can easily find the mean and variance. Why do you find mean and variance? End of the day, I need what? End of the day, I need sigma X, sigma Y. So I would need standard deviations. I would need mean and variance of each E of X and E of Y. Yes. And I also need E of XY also. Let's see how we find that. That is interesting. Yes. E of X, how do you find it? Very simple. X into P of X, right? X into P of X. But what is P of X here? Should I take the joint one or the additional one or the marginal one? Very simple. It is just P of X. One variable only defined. And in that case, it is obviously marginal. Yes. So if X is 1, then P of X is this. If X is 2, then P of X is this. If X is 3, then P of X is this. So just multiply, 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 add, add. Okay. That will give you this answer. Yes. The same way you can do it for expectation of X square as well. Square, square, square. Multiply, 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 add, add, add. Okay. Yes. So you can easily find the variance and standard deviation for X. Same way you can do it for Y as well. Right? So if we got this, How do I find expectation of XY? That is a weird guy, no? Yeah. How do I do that? Expectation of XY. So that is going to be summation of, generally if it is U of X, I take what? X into P of X. Right? Now it is U of XY. Two things are there. So in that case, I will take two things XY. And probability of two variables. Two variables now it should always be joint. So it's for all the values of X and Y, summation of XY into P of X comma Y will give you the E of XY value. So you can always use this E of XY. So you have gotten that, you can easily find the covariance. Now covariance by sigma X, sigma Y will give you the correlation coefficient. Simple, right? So yeah, X and Y are independent random variables, variances 2 and 3. Find the variance of 3x plus 4y. Variance of 3x plus 4y will be what? 3 square variance of x plus 4 square variance of y. That is the property, right? Property. They're independent random variables, so the covariance will be 0. That plus 2 covariance of x comma y will not come here. Yes. So 9 into, they have given us variances, you can just substitute it and get it. Okay. Just try solving this. Interesting one. So regression lines, that's the last concept here. So regression lines are also easier. So how do you do this? The regression equation of y on x, the regression equation of x on y, right? So the regression equation of y on x is nothing but, this is similar to y is equal to mx plus c, right? Y is equal to mx plus c. Generally, when you construct a line, this is how you construct it. Y minus y bar is equal to m into x minus x bar. Remember, we learned it in straight lines chapter 11th or 12th. Yeah. So the same way, this is going to be regarded as a slope kind of thing. Okay. X minus X bar is this, Y minus Y bar is this. So Y, so please remember this, regression equation of Y on X is nothing but Y minus Y bar is equal to R, Y on X na, sigma Y by sigma X. Yeah, X minus X bar. If it is X on Y na, it will start with X only. So X minus X bar is equal to R. X on Y, so sigma X by sigma Y. X on Y, so Y minus Y bar. Yes. And note this, both the regression lines, right? The regression lines on Y on X and X on Y meet at X bar Y bar. You can try solving these two equations. You will get the values of X and Y as X bar and Y bar. Okay. So they meet at X bar and Y bar. Okay. Next step. There's something called regression coefficient. Regression coefficient. BYX and BXY. Okay. BYX is nothing but it is defined on Y on X line. This is defined on X on Y line. BYX is nothing but generalizing it, basically. I don't want to put something like R sigma Y by sigma X, R sigma X by sigma Y. Rather, I just put BYX instead of R sigma Y by sigma X. I'd rather put BXY instead of R sigma X by sigma Y. This would be BXY. Yes, just substituting it, right? Yeah. So R sigma Y by sigma X, R sigma X by sigma Y. Yes. Beautiful. And you can see this. These are all simple derivations only. Okay. We very well know R is given by covariance by sigma X and sigma Y. Right. From there, you can easily define it. R is covariance of X comma Y by sigma X, sigma Y. Already you have one sigma Y and one sigma X. So sigma Y will cancel out. Sigma X into sigma X will be sigma X square, and that is variance. Okay. So just few derivations, you can note this down. Okay. If both BYX and BXY are positive, then R is given by the formula plus root of BXY, BYX. Similarly, if both are negative, then you put R is equal to minus root of BYX, BXY. Right? Yes. And there is a cool property, BYX by BXY is equal to sigma Y square by sigma X square. Okay. You can very well see this from the previous thing which we did. This previous thing which we did. If you try to divide both, the covariance will cancel off. This guy will come up. So BYX by BXY will be nothing but sigma Y square by sigma X square. Okay, beautiful. So if R is equal to 1 or minus 1, the regression lines coincide. If R is equal to 0, the regression lines are perpendicular. Okay, they've given two regression lines. Variance also they given. Find the mean value. Simple, right? Two regression lines meet at the mean values. Correct. Try solving them, get the mean values, right? That is going to be the intersection point. Correlation coefficient. How will I find correlation coefficient? Firstly, express this nicely in terms of y minus y bar is equal to m into x minus x bar. Basically, express it in terms of y is equal to mx plus c. Y is equal to mx plus c, right? So if you do that, it will look like this, right? What is m? M is going to give you the regression coefficient. M is going to give you the regression coefficient, just like how I defined it there. So this is y on x line. So this is byx. X on y line. So this is bxy. Okay. Beautiful. So byx into bxy is nothing but less than 1. Beautiful. Nice. So r is going to be given by root of bxy into byx. That's it. Okay. So we got the regression coefficients as well. How do you find the covariance? Again, we very well know that they have already given us sigma x square and byx, byxy both we found, right? Then we just need to find sigma y square, right? So we know the property byx by bxy is equal to sigma y square by sigma x square. Just using that. Okay. Beautiful. Let's say you are given a raw data like this. How do you find this? From a raw data, finding coefficient of correlation, regression equations, and substitution. So how do you do that? Same thing. Okay, you are going to use the same formulas. Okay. So firstly, you are making two random variables. One is x and one is y. One is x and one is y. Can I use the same formula and do it for x and y? Yes, you can. But these values are very much larger. And you want to reduce this. So I do what? I do something called normalization. Okay. So how do I normalize it? I normalize it about some value I choose. Preferably the mean, but any value works. Okay. X I put in one table. Y is one column. So U, I take another value called U and I subtract it from 32. This is going to give you nice values like this. Right? This is going to give you nice, very small values. Right? Similarly for V as well, very small values will be given. Okay. So you got U, you got V. So you can usually find u square, v square, right? And you can find ub as well, because you need to know expectation of uv minus expectation of u into expectation of v, right? Now take the expectation of all of these guys. How do you take the expectation? Sum it all up divided by total number. Sum it all up divided by total number. Yes. So u bar you can find it summation by total. V bar you can find summation by total. Covariance of u comma v is summation of. So where you very well know that covariance is nothing but what? Expectation of xy minus expectation of x into expectation of y. Expectation of x is just u bar. Expectation of y is just v bar. So in this case, it's just u and v. So we just substitute like that. Next, covariance of the expectation of x comma y. If it's x comma y, it has to be what? The all the values of x and y are x into y multiplied together, sum it all up, divided by total number. Yes, sum all the values of uv and divide by total number. That's going to give you the mean value. Yes. So that's it. You easily find it. So sigma u, sigma v as well. It is just sigma u square is given by the formula. Expectation of u, the expectation of u square minus expectation of u, the whole square. That's what they have done. Okay. So you can do that. Now, having gotten all the values, you can substitute in the correlation coefficient. And after that, you can find the values. So I easily I substituted in terms of x and y, I substituted u and v, right? But don't you think it should make some difference in the overall value? Don't you think? Yes. So what did I substitute? I substituted u is equal to x minus 32. V is equal to y minus 40. Then let's take expectation both sides, right? Then what is expectation of u is equal to expectation of x minus expectation of 32. Expectation of a constant is just a constant, right? So in that case, u of x is nothing but what? U of x nothing but a of u plus 32. U of u plus 32. That's it. I know what u of u is. I can just substitute as it is, right? Similarly, I substituted v is equal to y minus 40. So v bar is equal to y bar plus minus 40. So y bar is equal to v bar plus 40, right? Very easy. I know v bar. I can just substitute. Then don't you think? Okay, fine. Now you see this. Don't think this is a printing mistake. This is actual nice thing, right? Sigma x, sigma y, sigma u, sigma v. How are they equal? How are they equal? Right? Here also you should understand the property of variance. Right? Variance disregards these constants. This plus 32 and so on, it disregards. We very well saw that there, right? In the properties thing. Right? So sigma x will always be sigma u, sigma y will always be sigma v. That minus 32 or minus 40 doesn't matter. Yes. So we got all the values, just substitute in y on x line and x on y line. You get the nice equations. Then you can easily find the substitute. Right? So here I'm given the value of x equal to 30. I have to find the value of y. X equal to 30. I have to find the value of y. So I'll use it what? Y on x line. Y on x line. Okay. So that's it. So that's the end of fourth unit. We have seen it very nicely. Okay. You should not have it. You should not lose any of your marks here. Okay. So next, moving forward with one sec. Yes. Stop. This is one of the very simple MGF questions, right? Given P of x equal to 0 is this, P of x equal to 1 is this, P of x equal to 2 is this. What is mx of t? Very simple, right? If you want to find mx of t, it's just summation e power tx into P of x. For all the values of x, just substitute it. For all values. When x equal to 0, it is e power 0 t into probability of x equal to 0 is 1 by 4. Right? Plus, when x equal to 1, what it is? When x equal to 2, what it is? And so on. Right? MGF is given. This is a very nice question. Even I was not able to attempt it the first time. Very simple question actually. Mx of t is given. Find the value of p of x equal to 2. Mx of t is given. Find the value of p of x equal to 2. This is exploiting the property of MGF itself. What the property of MGF is e power tx into p of x, right? Summation of e power dx into p of x equal to x. That is the property of integration. Yes. Now x equal to 2 now, don't you think e power will have 2t? E power will have 2t. So the coefficient of e power 2t will be the probability of x equal to 2, right? The coefficient of e power 2t would be the probability of x equal to 2. So the answer is just 0.3. That's it. Okay. So you can go through this. So they have given MGF. You have to find this using sequence, or you can just compare it with T power R by R factorial to get the mu R dash. Okay. So again, we looked upon these basics, two-dimensional random variables. I don't want to go. You please solve this. Practice is essential for this. Okay. Uh, don't be overconfident in this uh, subject itself. Very simple subject, very easy subject, but your overconfidence might kill your grade. Okay. Yeah. Uh, yeah, I think we've gone through everything. We are just now left with the first unit and second unit. So yeah, a box contains 10 screws, 3 of which are defective. 2 screws are drawn at random with replacement. The probability that none of the screws is defective. Very simple. Defective probability is 3 by 10. Then the non-defective probability is 7 by 10. It is continuously happening, so 7 by 10 into 7 by 10. Both are independent because it's a replacement. So answer is 49%. None of these. Okay. Right. Two fried rice are so whenever you have these kind of dice problems, make sure you put the sample space nicely so that you avoid any silly mistakes you do. Yes, put the sample space, see which and all outcomes satisfy it, and find it. Very simple only. Right. A person on a trip has a choice between private car and public transport. The probability of using private car is 0.45, so public transport will be 0.55. And probably using by using public transport, bus is 0.55, so metro would be 0.45, right? So you have to find the individual probabilities, right? So car, you already know it. Car is 0.45 only. Okay. Next one, bus they're asking. So bus would be what? I have to first use the public transport. That probably would be 0.55. Then inside that, I have to use what? I have to use the probability of bus. That would be another 0.55. Okay. That I can do. Okay. Next step, public transport I have to use. Then the probability of metro would be 0.45. Okay. Just compute these values, that will be the answer. Okay. So you can always do this. Simple stuff. Simple stuff. Okay. Let me know if you have any queries here. Common generating function finding. Okay. Given a table like this, find the, I think you don't have coefficient of skewness kurtosis, just leave it. Value of k, mean, standard deviation. Very simple. Find all the, add of all the probabilities, get the value of k. Multiply, add the order that is going to give you mean. Find e of x square minus e of x the whole square and then take the root that will give you standard deviation. Okay. So I expect you all to practice some good enough problems for this. Don't be overconfident. I think that takes us to the end of this. Okay. And please do not miss out on unit 5. Go through it. Okay. All the very best. Go through the session uploaded for unit 5 as well. All the very best. I'm Judy. Thank you so much for attending. Sorry for the length of the session. Yeah. So everything is clear for everyone. Guys, quick thumbs up, please. Okay. Thank you so much. Yes. So, can someone give me the pattern, please? Pattern. You may stop the recording, please.